Hello and welcome to G Fun Facts Online, the show that digs deep into the science and history behind the world's most fascinating subjects. Today we're going underground. Deep, deep underground. We're venturing into a world hidden from sight, a realm of concrete, steel, and secrets, built to survive the unsurvivable. We're talking about hardened nuclear sites. These subterranean fortresses, scattered across the globe, are some of the most incredible engineering marvels ever created. They are silent sentinels, designed to withstand the single most destructive force humanity has ever unleashed. The very existence of these places tells a strange story about us. It's a story of our immense capacity for destruction and our equally powerful, relentless drive to survive. So grab your hard hat, because today we're exploring the geology, the blueprints, and the future of these shields against the unthinkable. How do you build a fortress to survive a nuclear apocalypse? Well, the answer doesn't start with blueprints or concrete. It starts with the ground itself. The very first line of defense is geology. Picking the right spot is the most critical step. Engineers and geologists search for incredibly stable geological formations. Think massive, ancient bodies of granite or other hard rock. Why? Because a giant slab of solid rock is a fantastic natural barrier. It helps absorb the earth-shattering seismic shockwaves from a nuclear blast and, just as importantly, it helps contain any potential radiation leaks from the facility itself. It's like nature's own vault. But here's where it gets tricky. It's a complex trade-off. While that super-dense hard rock offers amazing protection, it also has a downside. It's so solid that it can transmit shock forces more effectively than softer soil. Imagine hitting a steel plate with a hammer versus hitting a mound of dirt. The shock travels much further and faster through the steel. On top of that, imagine the sheer difficulty and cost of trying to excavate a massive cavern out of solid granite. It's a monumental task, and a noisy, obvious one, which increases the risk of the whole secret project being detected before it's even finished. So planners have to perform an incredibly delicate balancing act, weighing the protective qualities of the rock against the risks and costs of construction. They need to know everything about the site's geology, from the characteristics of the rock to the flow of groundwater, to make sure they're building their last resort on the strongest possible foundation. Once the perfect, or at least the best possible location is chosen, the real construction begins, and this is where we see some truly mind-bending engineering. The design of these underground forts is a masterclass in defensive architecture. The core principle guiding everything is a concept called super-hardening. It sounds like something out of a comic book, and honestly, it kind of is. Super-hardening means creating a structure that can withstand a near miss from a multi-megaton nuclear weapon. Let that sink in. A near miss. We're talking about forces that can level cities in an instant. How is that even possible? It's achieved through a multi-layered defense. The primary shield is concrete, but not just any concrete. We're talking about walls that are often several feet thick, and not just solid concrete either. They are heavily reinforced with a dense mesh of steel rebar, creating a composite material of incredible strength. To supplement this, other materials like lead or layers of packed earth are often included to absorb deadly gamma radiation. The goal is to create enough shear mass between the occupants and the blast to absorb the initial shockwave and block the radiation. But it's not just about thick walls. The designs themselves are incredibly clever. For example, some command and control capsules inside missile silos aren't rigidly fixed to the surrounding structure. Instead, they are mounted on giant springs or counterweights. So when the entire silo is violently shaken by a blast, the capsule inside can move and sway, absorbing the shock like a car's suspension system, protecting the crew and the delicate equipment inside. And of course, the best place for a hardened facility is underground. Being buried provides a massive, natural layer of protection from the blast, the heat, and the subsequent radioactive fallout. It also makes the site much harder for an enemy to find and target accurately. But how deep do you go? There's a general rule of thumb for simpler shelters, which is to have no more than 10 feet of packed dirt on top. This provides a good balance of protection, while still making it possible for the occupants to dig their way out if the entrance is blocked. But for the most critical facilities, the ones that need to guarantee survival, we're talking about depths of hundreds, sometimes even thousands of feet beneath the surface. Beyond the main structure, these sites are packed with specialized survival gear. You have massive blast doors, engineered marvels of steel and concrete that can weigh many tons, designed to seal shut and withstand the colossal pressure of a nuclear explosion. You have advanced ventilation systems with nuclear, biological, and chemical, or NBC filters, to provide a continuous supply of clean, breathable air no matter what's happening on the surface. And since you can't rely on the national grid in a nuclear war, these facilities have their own independent power sources, usually huge diesel generators with vast fuel reserves. They also have their own water storage and sanitation systems, often using septic tanks, creating a completely self-sufficient ecosystem designed to function for weeks, months, or even longer in total isolation. The history of these bunkers is, unsurprisingly, tied directly to the history of the Cold War. As the nuclear arms race between the United States and the Soviet Union escalated, so did the frantic construction of these hardened sites. It was a massive proliferation of underground structures, from huge command and control centers like the famous Cheyenne Mountain Complex, to thousands of individual missile silos and hardened aircraft shelters. The early designs from the 1950s and 60s were primarily focused on surviving the initial blast and the radioactive fallout. But as weapon technology got more sophisticated, the bunkers had to evolve. The game changer was the development of bunker buster munitions. These are bombs designed to penetrate deep into the earth before detonating, specifically to destroy underground targets. This new threat led to the era of super-hardening that we just talked about, forcing engineers to design even more robust, even more deeply buried facilities to counter these advanced weapons. The Cold War may be over, but its legacy is still etched into the landscape. Many of these once top-secret sites have been decommissioned. Some have been repurposed, while others are preserved as historical monuments or museums. You can actually visit some of them today, and it's a chilling experience to walk through those concrete corridors and see the blast doors and old computer terminals. It's a tangible glimpse into a time when the entire world stood on the very brink of nuclear annihilation. So what about today? Is there still a need for these incredible structures in the 21st century? The answer is a resounding yes. The nature of the threat has changed, but it hasn't disappeared. Modern facilities are being designed not just to withstand a nuclear attack, but also to protect against a wider range of threats. These include attacks with advanced conventional weapons, cyber attacks aimed at disabling their systems, and other forms of sabotage from both state and non-state actors. The engineering has also taken another leap forward. Designers are now using cutting-edge materials like high-performance steel alloys and even experimental self-healing concrete that can automatically repair small cracks. These modern fortresses are being equipped with sophisticated sensor systems and automated defenses to provide an early warning of an attack and to actively counter incoming threats. And the focus has expanded. It's no longer just about military command centers and missile silos. The lessons learned from building military bunkers are now being applied to protect our most critical civilian infrastructure. Think about nuclear power plants or long-term nuclear waste repositories. Placing these facilities deep underground is increasingly seen as the best way to enhance their safety and security, protecting them from both accidents and malicious attacks. From the careful selection of a granite mountain, to the complex layers of concrete and steel, to the advanced technology of today, the engineering of hardened nuclear sites is a field born from the darkest of necessities. It's a discipline that constantly pushes the boundaries of science and technology, always innovating to stay one step ahead of the very threats we create. These subterranean fortresses, hidden from view but always vigilant, are more than just bunkers. They are a powerful, concrete symbol of our species' complex nature and our enduring, stubborn will to survive, a final shield against the unthinkable. Thank you for tuning in to G Fun Facts Online. Join us next time as we uncover more amazing stories from the world of science and engineering.